Hello, welcome to our space science series. In this episode we will talk about dark matter. Dark matter is a mysterious component of the universe, making up about 27% of its total content. It doesn't emit, absorb, or reflect light, and is only detected through its gravitational effects. This invisible structure is crucial to understanding the cosmos. While dark energy drives the expansion of space, dark matter affects the motion of matter. Dark energy acts on empty space, expanding the universe, whereas dark matter provides extra gravitational pull, shaping the universe's structure. Our understanding of the cosmos is incomplete. We observe galaxies moving faster than visible matter can explain. This suggests the presence of unseen mass, highlighting a central problem in modern astrophysics. Stars at the edges of galaxies move faster than expected, suggesting extra mass we cannot see. This unexpected observation provides evidence for dark matter, which holds galaxies together. Gravity depends on mass, but visible mass predicts lower speeds than observed. This contradiction suggests missing mass, indicating something invisible must be there to explain the speeds. The hypothesis of dark matter suggests an invisible form of matter that interacts through gravity. It doesn't emit light and is made of unknown particles, providing the extra gravity needed to explain cosmic observations. Galaxy clusters should fly apart without extra mass. Dark matter provides the gravitational pull needed to keep them bound, offering further evidence of its existence. Gravitational lensing shows how mass bends light, revealing dark matter's presence. This effect helps us see exactly where dark matter is, as it distorts and magnifies distant galaxies. Dark matter doesn't emit light and interacts gravitationally. It's abundant, stable, and cold. While we have candidates like WIMPs and axions, its true nature remains a mystery, pointing to new physics. Dark matter is essential for forming galaxies and clusters. It attracts normal matter, drives hierarchical growth, and explains the cosmic web, playing a crucial role from the early universe to today. Dark matter makes up most of the universe's matter, outnumbering ordinary matter by about 5 to 1. It's the main ingredient holding galaxies and cosmic structures together, highlighting its cosmic significance. All evidence points to dark matter as the key to understanding the universe. It holds galaxies together, bends light, and shapes the cosmic web. Its gravitational fingerprint is everywhere, making it essential to cosmic structure.